Hello, good morning, friends. I hope you are fine. In the last class, we discussed about cohesion and adhesion. So we will continue with that chapter. I am sharing the screen. I hope it is visible to you. So this we have seen cohesion and adhesion. So today we will see with respect to viscosity. So what is viscosity? That we will see today. Okay. I hope it is visible to you now. Viscosity. So what exactly is viscosity? Viscosity is the property by virtue of which fluid offers resistance against the flow of shear deformation. So what is happening in case of viscosity? As we have seen different properties of fluid such as specific weight, specific gravity, density and all. This is also one more property that is known as viscosity. So what exactly is viscosity? Viscosity is the property of a fluid by virtue of which the fluid offers resistance against flow or shear deformation. So what is the fluid is doing? It is offering resistance to the flow of motion. It is not moving forward. In other words, it is the reluctance of the fluid to flow. So viscous force is the force of resistance offered by a layer or fluid for the motion of another layer. So the best example for understanding viscosity is if suppose you take your honey. If you pour honey on a glass, what will happen? Initially, it will start to flow, but after some time, it will stop. Why it is not flowing? It is due to viscosity. That is the property of a fluid to offer resistance against flow. In case of liquids, viscosity is due to cohesive force between molecules of adjacent layers of liquid. So, in case of liquids, for example, petrol, oil, suppose what is happening? The viscosity is due to cohesive force between molecules of adjacent layers of liquid. So, what is cohesive force? Cohesive force is nothing but force acting between molecules of same kind. So, as a result of which, what is happening? The fluid is not flowing freely. For example, if you drop it of petrol or kerosene, if it is a drop on a floor, what will happen? Patches will form and it will not flow. This is also due to the cohesive force. This cohesive force is nothing but your what you can say viscosity. So in case of gases, molecular activity between the adjacent layer is the cause of viscosity. As we have said that in case of liquid, the cohesive force is responsible for viscosity. Similarly, in case of gases, what is happening? The between adjacent layer, molecular activity between adjacent layer is the cause of viscosity. Now we will see Newton's law of viscosity. I hope it is visible to you. If not, wait 1 second. I'm stop sharing. Once again, I will share you. There was a technical problem. Now, wait. I hope it is visible to you now. Newton's law of viscosity. So how we are understanding Newton's law of viscosity with the help of this sketch. So what we are doing, let us consider a liquid between the fixed plate and the movable plate at a distance y apart. So for understanding Newton's law of viscosity, what we are assuming, we are considering a liquid between the fixed plate and the movable plate at a distance y apart. So how much is the distance between the fixed plate and movable plate? The distance is about y. A is the constant. A is the contact area or wetted area of the movable plate. So how much is the area of contact? A. F is the force required to move the plate with the velocity capital U. So in order to move the plate, you require some force. That force we are assuming it to be F. And how much velocity we are applying? U. So according to Newton's law, shear stress is proportional to shear strain. So what we are assuming? As per Newton's law, the shear stress is proportional to shear strain. F is proportional to A. First, we are assuming the force acting on the fluid is proportional to contact area or wetted area. Similarly, this force is inversely proportional to the distance y between the fixed plate and the movable plate. That is, F is inversely proportional to 1 by y, or is 1 proportional to y. And F is also directly proportional to what? The velocity U, which is required to move the plate. Therefore, F is proportional to A into U divided by Y. So in order to remove this proportionality constant, we introduce a new constant mu. This constant of proportionality is called dynamic viscosity or absolute viscosity or coefficient of viscosity or simply viscosity of the fluid. This is very important. What Newton's law of viscosity states, the shear stress acting on the fluid element is directly proportional to shear strain. F is proportional to A into U divided by Y. Or in order to remove this proportionality constant, F is equal to mu into AU by Y, where mu is the constant of proportionality and it is called as dynamic viscosity or absolute viscosity or coefficient of viscosity. And your u is nothing but the force speed required to move the velocity required to move the plane, or F by A is equal to mu into u by y. So this F by A is equal to nothing but your shear stress, which is denoted by symbol tau. Tau is equal to mu into u by y. So tau is the force required per unit area and it is called as shear stress. The above equation is called Newton's law of viscosity. That is, tau is equal to mu into u by y is known as your Newton's law of viscosity. Once again, I will just revise it. You just listen it carefully. So what Newton's law of viscosity is stated, the shear stress acting on a fluid element is directly proportional to shear strain. Or what you can see in other words, F is proportional to A into U by Y, or F is equal to mu into A U by Y, or F by A is equal to mu into U by Y. Therefore, your 2 is equal to mu into U by Y. This 2 is the force required per unit area and it is called as shear stress. Shear stress 2 is directly proportional to shear strain. The shear strain nothing but U by Y. So this above equation is called Newton's law of viscosity. Now, velocity gradient or rate of shear strain. Till now, we are able to understand what is my viscosity, what is the Newton's law of viscosity, and what is shear stress. Now, we need to understand what is shear strain. So, velocity gradient or rate of shear strain. It is the difference in velocity per unit distance between any two layers. So, how we are defining velocity gradient or rate of shear strain? It is the difference in velocity per unit distance between any two layers. If suppose if the velocity profile is linear, then velocity gradient is given by u by y. And if the velocity profile is non-linear, then it is given as du by dy. So velocity gradient, how we are defining? It is the difference in velocity per unit distance between any two layers. So what was the difference in between any two layers? Y, and difference in velocity we are calculating as u. So if the velocity profile is linear, then it is denoted by u by y, and if it is non-linear, it is denoted as du by dy. So what is the SI unit of force? Newton. And the unit of distance between the two plates y is nothing but meter. And the unit of velocity is meter per second. So the unit of velocity gradient is equal to u by y, meter per second divided by meter. So it can cancel. It what will remain? Per second. And what is the unit of dynamic velocity? Tau. It is nothing but tau is equal to mu into u by y. Unit of dynamic viscosity is tau is equal to mu into u by y, or your mu is equal to tau into y by u. So it all gets cancelled. Finally, you are remaining with meter square. So what is the unit of dynamic viscosity? Newton second per meter square. Or in series system, it is dyne second per centimeter square, and it also called as poise. So this will be important while solving the numerical problems. What is the SI unit of shear, what you can say, viscosity, and what is the SI unit of, what is the series unit of dynamic viscosity? So it is nothing but poise. So how to convert poise? If the value of mu, that is coefficient of viscosity, is in poise, multiply by 0.1 to get in SI unit. Now we are familiar with dynamic viscosity. Now we will see one more type of viscosity, that is known as kinematic viscosity. So how you will define kinematic viscosity? Kinematic viscosity is the ratio of dynamic viscosity of the fluids to its mass density. So how we are defining kinematic viscosity? It is the ratio of dynamic viscosity of the fluid to its mass density. Dynamic viscosity is mu, that is dynamic viscosity divided by mass density rho. So the unit, what will be the SI unit of kinematic viscosity? Mu by rho, meter square per second, because the unit for mu is Newton second per meter square. So all gets cancelled. Finally we are remaining with meter square per second. And the unit of kinematic viscosity in CGS system is centimeter square per second, and it is also called as Stokes. If the value of kinematic viscosity is given in Stokes, multiply by 10 raised to minus 4 in order to get into meter square per second. So this is also very important. Kinematic viscosity, dynamic viscosity, what do you mean by viscosity? What are the Newton's law of viscosity? So it is entirely about viscosity. Now in order to understand this concept of the property of viscosity, we will solve some numerical problems. So the viscosity of water is 0.01 poise. Find its kinematic viscosity if specific gravity is 0.998. So kinematic viscosity you need to calculate. Dynamic viscosity, sorry, viscosity of water is 0.01 poise. That is, mu is given to you as 0.01 p. We need to calculate kV, that is kinematic viscosity, and the specific gravity is also given as 0.998. So how you will calculate? Kinematic viscosity is equal to mu by rho. Therefore kinematic viscosity is equal to 0.01. First, as we have seen that we need to convert this poise to what you can say SI unit, meter square per second. How you will do that? You multiply by zero point 0.1. So 0.01 into zero point 0.1. So it comes out to be 0.001. This is mu. Rho is given to you. How much? Rho is not given to you. Actually, specific gravity is given to you. So you need to remember that formula. That is specific gravity equal to density of fluid by density of standard fluid. So if using that formula, you need to calculate rho. So it will be equal to 0.998 into 1000, because specific density of water is 1000. So density of fluid comes out to be 998 kg per meter cube. So using that, kinematic viscosity equal to 0.001 divided by 998. So it comes out to be 1 into 10 raised to 6 meter square per second. So we will solve one more problem. A plate at a distance 0.0254 mm from a fixed plate moves at 0.61 meter per second and requires a force of 1.962 Newton per meter square area of plate. Determine dynamic viscosity of liquid between the plates. So what you need to calculate, a plate is there which is at a distance of 0.0254 mm. So y is given to you. Distance between fixed plate and movable plate is given to us 0.0254 mm. So you convert this into meter. It comes out to be 0.02454 into 10 raised to minus 3 meter. At a distance, and the velocity required to move the full plate u is equal to 0.61 meter per second. Requires a force of 1.962 Newton per meter square. 2 is given to you. How much? 1.962 Newton per meter square. What you need to calculate? Dynamic viscosity. Determine dynamic viscosity of liquid between the plates. You need to determine dynamic viscosity, mu. So assuming linear velocity distribution, tau is equal to mu into u by y. So as I said you, there are two cases. The velocity profile may be linear or non-linear. Based on that, your Newton's law of viscosity will vary. As we are assuming this to be linear velocity distribution, so tau is equal to u into y. Tau is given to us 1.962. Mu you need to calculate. Capital U is also given to you 0.61. Y is also given to you as 0.0254 into 10 raised to minus 3. So if you do the calculations, it comes out to be mu. Dynamic viscosity of liquid between the plate is equal to 8.17 into 10 raised to minus 5 Newton second per meter square. One more problem we will solve it. After that we will close this topic. A flat plate is sliding at a constant velocity of 5 meter per second on a large horizontal table. So what is happening? A flat plate is there which is sliding at a constant velocity of 5 meter per second. So capital U is given to you. That is velocity required to move the plate. Capital U is given to you. It is nothing but 5 meter per second on a large horizontal table. On a large horizontal table. A thin layer of oil of absolute viscosity 0.4 Newton second per meter square is given to you. What it is? 0.4 mu. That is dynamic viscosity or absolute viscosity, both mean the same. It is given to us 0.4 Newton second per meter square. Separates the plate from the table. So what you need to calculate? Calculate the thickness of the film. You need to calculate the thickness of the film Y in to limit the shear stress in the layer to 1 kPa. 2 is given to you. That is shear stress is given to us 1 kilopascal. So what are the things given to you? 2 is equal to 1 kilopascal. U is equal to 5 meter per second. And mu is equal to 0.4 Newton second per meter square. So applying Newton's viscosity law for the oil film, tau is equal to mu into du by dy. R is equal to mu into u by y. So tau is known to you how much it is? 1,001 kilopascal. We are converting this into Newton per meter square. Tau is equal to 1,000. Mu is nothing but 0.4. Capital U is 5. Y is you need to calculate that is distance between the fixed place and moving. So it comes out to be y is equal to 2 into 10 raised to minus 3 or meter or in it is equal to 2 mm. I hope the concept of viscosity is clear to you. Now we will go to the next topic that is known as types of fluid. So there are different types of fluid. First is ideal fluid, next is real fluid, third is Newtonian fluid, fourth is non-Newtonian fluid, fifth is ideal plastic fluid. So we have classified the fluids into five types, that is ideal fluid, real fluid, Newtonian fluid, non-Newtonian fluid, and ideal plastic fluid. five types of fluids we have, what you can say, classified. So what is the ideal fluid? A fluid which is incompressible and is having no viscosity is known as ideal fluid. So how we are defining ideal fluid? ऐसा फ्लूइड जो कि इनकम्प्रेसिबल है, उसको आप कंप्रेस नहीं कर सकते और उसकी कोई वेलोसिटी नहीं, तो इट इज नोन एज आइडियल फ्लूइड. Ideal fluid is only an imaginary fluid as all the fluid which exists has some viscosity. See here, ideal fluid is imaginary fluid. We are assuming that such type of fluid exists, but in reality such type of fluid does not exist. A fluid which is incompressible and is having no viscosity is termed as ideal fluid. Next type of fluid is real fluid. A real fluid which possesses a velocity is known as real fluid. All the fluids in actual practice are real fluid. So all the fluids which exist are nothing but real fluid because they have some viscosity in it. Next is Newtonian fluid. So how you will define Newtonian fluid? A real fluid in which shear stress is directly proportional to shear stress strain, that is velocity gradient, is Newtonian fluid. So as the name itself indicates, a fluid which obeys Newton's law of viscosity, that is shear stress is directly proportional to shear strain, is known as your Newtonian fluid. Next is non-Newtonian fluid. So how you will define non-Newtonian fluid? A real fluid which in which the shear stress is not proportional to rate of shear strain or velocity gradient is known as non-velocity, non-Newtonian fluid. That is, a fluid which does not obey Newton's law of viscosity is known as non-Newtonian fluid. Last but not the least, ideal plastic fluid. A real fluid in which the shear stress is more than the yield value and the shear stress is proportional to the rate of shear strain is known as ideal plastic fluid. See here, ideal plastic fluid, carefully you see, it is nothing but a real fluid only in which the shear stress is more than the yield value. Five types of fluids are there, don't get confused. Ideal fluid, real fluid, Newtonian fluid, non-Newtonian fluid, and ideal plastic fluid. Ideal fluid is type of fluid which is incompressible and has no viscosity. This type of fluid does not exist because in reality हर फ्लूइड के पास कुछ ना कुछ विस्कोसिटी रहती है, तो ये आइडियल फ्लूइड जो हम बोल रहे हैं एग्जिस्ट ही नहीं करता. Next is a real fluid. So what is real fluid? A fluid which possesses viscosity. So all the fluids in nature possess viscosity. So all the fluids are real fluid only. Next is Newtonian fluid. How you will define Newtonian fluid? A fluid which obeys Newton's law of viscosity. That is shear stress is that proportional to shear strain. That is nothing but your Newtonian fluid. Next is non-Newtonian fluid. Non-Newtonian fluid is nothing but a real fluid which does not obey Newton's law of viscosity. शेयर स्ट्रेस इज डायरेक्ट प्रोपोर्शनल शेयर स्ट्रेन जो नॉन न्यूटोनियन फ्लूइड है वो जो फॉलो नहीं करता, इट इज नथिंग बट नॉन न्यूटोनियन फ्लूइड. लास्ट बट नॉट द लीस्ट, आइडियल प्लास्टिक फ्लूइड. सो व्हाट इज आइडियल प्लास्टिक फ्लूइड? ए फ्लूइड, a real fluid in which the shear stress is more than the yield value and the shear stress is proportional to rate of shear strain. ऐसा रियल फ्लूइड जिसमें शेयर स्ट्रेस ज्यादा है ईल वैल्यू से और शेयर स्ट्रेस प्रोपोर्शनल थे रेट ऑफ शेयर स्ट्रेन से इज नोन एज आइडियल प्लास्टिक फ्लूइड. So this is the graph in order to understand different types of fluid. Ideal fluid, we have drawn a graph of shear stress versus shear strain. The shear strain stress should have been somewhat here. So ideal fluid, that is a type of fluid which has no viscosity. It is placed here. Whereas the next type of fluid, Newtonian fluid, is placed here in which shear stress is directly proportional to shear strain. Non-Newtonian fluid is the opposite direction. Shear stress is not proportional to shear strain. Last is ideal plastic fluid in which the yield is more than shear stress. Now, next topic we need to understand is surface tension and capillarity. The surface tension is also a very important topic. So we will see what exactly is surface tension. So surface tension is defined as the tensile force acting on the surface of a liquid in contact with the gas or on the surface between two immiscible liquids. So how we are defining surface tension? Surface tension is nothing but it is also a property of a fluid like specific weight, density, specific gravity, specific volume. or what you can say cohesion, adhesion, viscosity. Surface tension is also a property of a fluid. It is defined as tensile force acting on the surface of a liquid in contact with a gas or on the surface between two immiscible liquids. So how you will define two miscible liquids? Liquids which cannot be mixed. For example, if you mix water with petrol, it may seems to be mixed, but there will be separation between the two. So such type of liquids are termed as immiscible liquids. So how we are defining surface tension? It is defined as a tensile force acting on the surface of a liquid. ऐसी फोर टेंसाइल फोर्स जो कि एक्ट कर रही सरफेस पे ऐसे लिक्विड के जो कि कांटेक्ट में है गैस से या फिर किसी और इमिसिबल लिक्विड से, जो हमें ऐसा दिखता है कि बीच में एक मेम्ब्रेन है. The magnitude of this force per unit length of the free surface will have the same value as the surface energy per unit mass. So how we are denoting surface tension? Sigma. In other words, you can say surface tension is nothing but tensile force acting on the surface of a liquid. Newton per meter. Force per unit length. So the SI unit for surface tension is a Newton per meter. So in order to understand the phenomenon of surface tension in detail, what you can do is you can assume this sketch. That is molecule A is there, molecule B is there, molecule C is there, and free surface is there. So how we are explaining the phenomenon of surface tension, you just see. The phenomenon of surface tension is explained by considering this figure. So we are considering this figure in which molecules A, B and C of a liquid in a mass of liquids are present. The molecule A is attracted in all directions equally by the surrounding molecules of the liquid. So what is happening? The molecule A is attracted in all the directions equally both by the surrounding molecules of the liquid. So what is happening? This molecule A is attracted by all the molecules, molecule attracted in all the direction equally by the surrounding molecule. Thus, the resulting force acting on the molecule A is zero. As it is free to move, the force acting on this molecule is zero. But the molecule B, which is situated near the free surface, is acted upon by upward and downward forces which are unbalanced. So if you see molecule B, it is 70 to 80% inserted in water. So as a result of which the forces acting on it are unbalanced. Whereas the molecule C, if you see it is situated on the free surface of the liquid, does experience a resultant downward force. All the molecules on the free surface experience a downward force. Thus, the free surface on the liquid, like a very thin film membrane and tension on the surface of the liquid, act to it and elastic membrane under tension. So if you see molecule C, it is exactly 50% inserted in water, 50% it is exposed to atmosphere. So the center or the radii of it is acting as a membrane between the surface and the liquid. So the force acting on this molecule C is termed as your surface tension. I hope you understand this. Once again, I will try to explain you what is exactly surface tension. Surface tension is nothing but tensile force acting on the surface of a liquid contact with gas or on the surface between two immiscible liquids. तो क्या है सरफेस टेंशन? एक ऐसी फोर्स है, टेंसाइल फोर्स, जो कि एक्ट कर रही बिटवीन द surface of a liquid or a gas, which is explained in this figure, or force acting between two immiscible liquids is termed as your surface tension. So the SI unit of surface tension is Newton per meter. So the molecule A, as it is present inside the water, it is experiencing the force in all the direction, as a result of which the resultant is zero. Whereas the molecule B is 70 to 80% inserted in water, so it is also not experiencing the tensile force, surface tension, as the forces are unbalanced. Whereas the molecule C, it is completely 50% it is inside water, 50% is outside. So as a result of which the surface is acting as tensile surface tension. I hope you understood it. If not, we will continue it in the next class. Have a nice day.